Muito bem, acho que a gente já pode começar. Bom, primeiramente, bom dia a todos. Eu espero que todos estejam bem. Sejam muito bem-vindos ao webinar organizado pela OpenCAD. Para quem não me conhece, meu nome é Eduardo, eu sou engenheiro de produtos aqui da OpenCAD. Hoje nós vamos falar sobre modelos de perfuração, né? Que é muito importante aí para o setor de petróleo e gás, né? E para isso nós trouxemos aqui o engenheiro de aplicação, o Mehdi Degor. Mehdi é doutor em engenharia eletrônica, perdão. Possui experiência em indústria petroquímica, onde trabalhou por 2 anos como engenheiro de instrumentação, incluindo calibração, sistema de controle, PLC e sensores. Além disso, possui uma vasta experiência como docente em universidades e também como desenvolvedor web, ok? Aí ao lado, pessoal, nós temos um painel onde vocês podem ir fazendo as perguntas durante a apresentação, ok? A apresentação, inclusive, que será feita em inglês, mas vocês podem fazer perguntas em português, caso se sintam mais à vontade, né, mais confortável. Pois, além de mim, temos aqui também conosco a nossa gerente de engenharia da OpenCAD, a Erika Libani, que também vai nos ajudar a dar suporte, ok? So, Mehdi, thank you again for supporting this event. I'm sure your presentation will be very interesting for the attendees.
Thank you.
So, all of you, enjoy and thank you. Mehdi,
okay.
Go ahead.
Okay, thank you, Eduardo, and hello, everyone. My name is Mehdi. As Eduardo introduced me, my name is Mehdi, and I have PhD in electronic engineering. I have 2 years experience working in petrochemical company as an instrumentation and maintenance with calibration devices like pressure gauge, temperature gauge, PLC, and also I have almost 11 years teaching at university as a faculty member, and now I'm an application engineer at OpenCAD company. I consider OpenCAD as a connection between industry and university because now we are in touch with big companies and industry in Brazil, and also we are focusing on the simulating and modeling simulation that it's the area of universities. So because of that, I consider OpenCAD as this connection between university and industry. Okay, first of all, I want to talk about the digital twins. What is the digital twins? Actually, digital twins is the model that represent the real system. Okay, we have a real system that is already working, and now this digital twin is a model that we created, up-to-date model that shows the system. But why we should do that? The advantages of this one, let I put it on the, okay, now we can focus on this presentation. It has 4 reasons, as you can see here. In the case of optimization, if we want to do any change in our system that is already working, so it's too expensive if I want to do any change. So we can have a model that test it, and if it is really working, then we can implement it on the real system. Another thing is that predictive maintenance. It's good option for us to have a productive instrument and also schedule a time for maintenance to have a high performance devices. And also another thing is anomaly detection. We know the real behavior of the system, the system behavior. If there is a deviation of the expected behavior, then we can realize, and it can help us to change and have a quick action for that. If there is a deviation, the behavior, from the expected behavior that we know inside the system model. And at the end, fault isolation, if any fault occur in our system, then we can quickly isolate it, not to disturb other part of the system. Okay, now we know the importance of digital twin and the modeling. So we are trying to create a model. I just try to show you how we can do. We just start with design. We can create our design, and then we have this industrial controller. We can download it on this controller and see. And at the end, if everything is okay, then implement it on the real system. Something that we have when we create our design, we can generate the C code, and then we use a real-time instrument like a SpeedGoat, or we can have download generate the PLC code and then download in our PLC. And at the end, if everything is okay, then we can implement it in the real system. So, okay, now I want to quickly mention about this MATLAB and the toolbox that we really need. Something that if we open the Simulink, the requirements, the initial requirements that we need, I just select some important part, like commonly used block that we can see. If we need to do any mathematic part, we need the switch, the part that we require, we can find here, integrative and gain or other part. We can see the continuous part. For example, if you need the PID controller, we can find it here. The transfer function, you can find it here. Integrator. So this part is too important for us. And then if I want to mention, you can see the dashboard, for example, the gauge or the toggle switch, some part that in this webinar I will use and show you how we can use in our model. And also we have a math operator. If you know about the mathematics behind your system, then you can use all of this mathematic part to create your equation also. And something else, for example, the sync to show your result, for example, to display as a scope. And also some sources that you can see here, for example, the pulse generator that we have here, pulse generator, the sinus wave or other part, the clock that we normally use in our system, the ramp. So it's some basic requirements that we need. In advanced model that we want to use, we should use Simscape. In Simscape, if you see, we have a Simscape electrical, we have a Simscape fluid, multi-body. So we need to know about this, and we really use this Simscape. For example, Simscape electrical, if you see, we have a passive model, we have some semiconductor like a diode, we have some sources, some machine that we can use, the circuit and switch, the breaker. And also the part of fluid that here as oil and gas we use too much in this case, gas, thermal liquid, also the actuator, valves, everything you can find here inside the fluid. And at the end, something that we use, multi-body or mechanical, that you can see a lot of joint or gear or some part that as a mechanical part that we use. So that's it. It's a short review of something that we have in MATLAB. As an example, if we open the MATLAB and open the Simulink, just first I want to mention that MATLAB is something that you can use something simple, for example, some equation, some 2 + 2, something simple, and some sophisticated equation that we can solve with that. Okay, if we open the Simulink, then we can see we have a blank model. Inside the blank model is nothing. You can just open the library, and then, for example, you can put one source like a sinus, and also one as a sink, as a scope, and then quickly connect to each other and easily see the result like this. Okay, and see the result easily. You can find it. And in the advanced model, if you go to open the Simulink and go to the Simscape, here in Simscape, you can see in Simscape we have some, for each one we have one template. For example, for electrical, for multibody, if I open multibody, then you can see there is a template. I wrote this one. There is the template here, the minimum requirements that we have. Okay, I just want to mention one simple model that help us to create the drilling part. Okay, as you see here, we have one box, and what I want to create one model to move it up and down. Okay, so I have this box. Easily I can connect the part to each other, the element. I open the library, go to the Simscape part. If you find the Simscape and Simscape multibody, then something that I need here, I need one joint, revolute joint. I drag and drop easily here and connect to other part, the initial part that I have, and then I select one cylindrical solid. What is this cylindrical solid? That I turn it. It's like a holder that I want later keep it and move it up and down. Okay, so I put it here, and then 1 meter is too much. I select 0.1 and apply, and okay. Then something that I need belt and cable. If you see belt and cable, easily I can drag and drop this cable here, and also the end belt, and this configuration that I will put here. So easily I can connect the part to each other. Let I just turn it, and this one also. Okay, now everything is okay. Then just 10 is too much. I select 0.3. That's it. Everything is okay, and I just want to run this system and see how does it work. Just some requirements that we need. I put here, okay, and connect to the bed. And this position I put minus. Also, this axis I select the axis, standard axis, minus y direction. It's something that I select, and everything is okay now. Let's see, run simple design that we create. I want to put this box up, move up and down, that hold by this cylindrical solid, and this cable do the actions. Let me see. Okay, before it go down, I just zoom out and I show you. If you see, we have exactly this holder that I show you, and this box that want to go up and down, and then just I zoom out, let I run to see all the part. Okay, so it's exactly the initial thing that we can use as a drilling later. You can see easily we can create something that can go up and down. It's one design model that we can use. And a good option in MATLAB is MATLAB has the ability to connect with the other software. For example, I create something in SolidWorks. Now I can import it here. I don't want this box that create something else. For example, I found one website that you can find some model. For example, if you search crane hook and then search, you can find a lot of hook here, crane hook. I select one like this, and then you can see, you can find a lot of formats. For example, CATIA, AutoCAD. I select the SolidWorks format. You may want to create your own design. Okay, I just want to show how you can import SolidWorks and connect the SolidWorks with MATLAB. Easily you can download it. I downloaded it before, and just I will import it here. If you see, I put one file solid and then some configuration. I select my file that I downloaded. I put it here. It is exactly the model that the SolidWorks that I import in my Simulink. And then I can give, for example, a mass like 100 kilogram to that. And then in the case of direction, also I should put, because I selected -y here, I also select -y, and then save it and apply and run. So just connect to my design. Everything is okay. Now I can run it. Okay, I will run this design and you will see instead of that box, now I have my design from the SolidWorks. It was from SolidWorks. Now I import it here, and it will be other parts that help me to guide me to the drilling part, drilling model, like this. Okay, and then you can turn it and see how it will be. Now that we know how we can create a simple model, now I can go ahead and open my real model that can show you how we can use Simulink. That I put it in pass, and then that's it. I open my model, drilling model, something that we have. And it will be the digital twin for my system, okay? The structure would be like this. Now we know the minimum requirement for that, okay? If I want to explain about it, I can divide it to two parts. One part, if you see this part of mechanical part, the belt, cable, all you can find here, and also this part of software that you can write the code. If you just double click on it, then you can see the state flow, the algorithm, all parts that you want. You can click and see the mathematics behind your model. You can change any part. For example, in the case of this cable that I mentioned, you just can right click on it, and it has a great help. It can help you, for example, introduce the belt cable and all the information that you need about this cable, and even a lot of examples that you can use. For example, tower crane, you can open and know how we can use of this belt. Or other part, for example, you can just go ahead and see the part that you can write a code inside. For example, this one, or the game, just right click and see the help and all the information. It's something that you can use and be familiar with this structure, this element. And also another part would be the monitoring part that you can see. As I told you, just you can right click and in help you can find it, this gauge, that how, and maybe other example about it. Okay, now I run it. I want to run my model. Something that I expect to see, the speed of motor, the torque, the power of the engine, if there is any change, how we can do reactive. The AC motor, we have the AC motor here, this AC motor inside this block. Okay, let I run it. Compiling first and then show you. It's the design that we create maybe on the software like a SolidWorks or other software. Then that's it. You can see we import our design inside the MATLAB, and now we can control it from our Simulink. For example, we can see the motor speed, how it can change. What if I do any change? For example, here we have auto driller. I can turn off the auto driller and then see what will happen if I change, if I improve the load, or if I increase. You can see how gauge can change the pressure on the motor, and then back to the normal auto driller that we can see here. Also, we can see the speed torque of this motor. What if we do any change inside our motor or our load? It can help us in this case to see the speed, the torque, the power, the minimum requirement. In the case of optimization, if you need to do any optimization, then you can see here. Also, you can see the drive speed limit, something that you can find it here. And the load measurement also, you can see the behavior of the load measurement. So it's this model can help us as a digital twin, can help us to see if we need to do any change, if we need to do any optimization, what should we do in this case. So that's it. Let me see if anything else. We can also change the limit, change it and see the behavior, turn off, turn on, and see the reaction of the motor. It's one design that we could create inside the MATLAB and see the digital twin, how it can work. Now, if you have any question, I can answer, but let I stop it. Before I finish this modeling, I want to first let me show you the minimum requirement for this one. If you see, we need the Simulink toolbox, the Stateflow, the Simscape electrical, multibody, and utilities. It's all toolbox that we need inside our model. And then another advantages that I can mention in MATLAB. For example, imagine I create this app, and then in my company, just I have access to the MATLAB and license, but I want to give this app that I created, I want let all the employees in my company see. For example, what if I change something? What if I change anything and see the behavior? Then just we have something in MATLAB, another option, MATLAB Web App Server, that then you can just, with one link like this, I created this design, okay, and then I could have one server on my computer. It gives me one link. I just give the link to the end user, and they just by URL on the browser, they can easily access to something that I created. For example, I created now I have 4 app here. The user just by browser like Google Chrome, without install MATLAB or any other software, they just can see how they can have a change inside this app and see the result. It's something that we can use inside MATLAB. Just we can create the design and then create the app and put it on the server. That's it. And the last thing that I can mention is that for those who are watching this webinar, it's better to start with the MATLAB Online, that easily by creating the personal email, you can by personal email you can create one account and then see everything MATLAB inside the MATLAB. All the things that I create, open the Simulink easily. Before access to the trial version, I suggest this. You can easily open and see, create your model. Exactly something that I did. You can do that in your system. It's online MATLAB. It's not my MATLAB. It's online MATLAB. And then go ahead and to the next step to using a trial version. So that's it. If you have any question, I can answer. Thank you. Eduardo and Erica, if you help me in this case.
Okay. Thank you very much, Mehdi. Let me check. We have some question here. Pessoal, se tiver alguma pergunta, pode fazer aí, tá? O tempo nosso também já está quase acabando aqui. De qualquer forma, antes de encerrar, nós aqui da OpenCard, pessoal, gostaria de agradecer muito a presença de vocês, tá? Conosco aqui hoje. Ao final, eu esqueci de comentar isso no começo, vocês receberão um breve questionário, tá? Para o feedback deste webinar. Nele, inclusive, se você tem alguma sugestão ou dúvida mais a fundo, né, que queira nos comunicar, basta entrar lá, tá? Assim que fechar aqui, vocês já vão receber esse questionário e que nós o responderemos o quanto antes, tá? Esse vídeo, inclusive, o pessoal às vezes fica com dúvida, né? Esse vídeo, inclusive, vai para o nosso canal no YouTube, tá? Então, se você gostou, vai lá, deixa o like, né? Compartilha com mais pessoas, com seu amigo que é da área, que tem interesse nisso, né? Nesse tema que é muito importante para nós, o Digital Twins, né? E todas essas ferramentas que a Mefix, né, oferece, né? Isso vai estar ajudando muita gente a fazer com que essas ferramentas importantes cheguem a mais pessoas, ok? Eu acho que é isso. No mais, eu agradeço muito. Forte abraço a todos. Excelente dia para vocês e uma boa semana.